All right, this is 12-2 conditional probability. And I got this problem up here to make you kind of realize what's going on. So this is the first question is something from 12-1. What is the probability of rolling a pair of dice and having a sum of 9? And I'm going to do something kind of boring. It's called the sample space, and you should too, because the sample space is something that needs to be on our minds. Now, what we're doing is we're rolling 2 dice. So I'm going through all the situations where the first die is a 1. And then I'm just going to keep moving forward. All the situations where the first die is a 2. And, you could have a 2 and a 3, 2 and a 4, 2 and a 5, etc. And the sample space is such a big deal. Like, it really is. Most people don't think about the sample space. And by and large, nobody's really asking you to write out a sample space for every problem because you just don't have that kind of time in your life to do it. But it needs to be something in the back of your mind. In the back of your mind, I've already gotten off by rant talking. In the back of your mind, you need to be thinking about all the possible outcomes. Now, some of the stuff we're going to get into pretty soon, the numbers are just so mind-boggling big that you can't really do a sample space anymore. But you can still kind of be thinking about what's there. What are some of the outcomes? And that's what a sample space is. A sample space is a list of all possible outcomes. And if a kid is willing to do the sample space a couple of times, they'll have a much better understanding of possible outcomes. So here's the sample space of rolling 2 die. And so what's going to happen? Now, the probability of rolling a pair of dice having a sum of 9, that's going to happen in 4 places. And the sample space does give kids at least an idea of where to see that. Hopefully we know what the word sum means. If we don't, we have a big problem. But 3 and 6 make 9, 4 and 5 make 9, 5 and 4 make 9, and 6 and 3 make 9. And it's kind of cool that happened on a diagonal like that, but they did. But there's 4 events out of 36. There's 36 guys here, which is 1 in 9. So you have a 1 in 9 probability of doing that. And that's a sample space. Now, obviously, there's other ways of doing this mentally, obviously. What is the probability of rolling a pair of dice and having a sum of 9 given? So given the first die was a 3, it is set in stone that the first roll is a 3. So the only thing I care about visually is all the stuff on the 3's columns. And there's only one thing there. There's one. It's this guy right here of 6. Now, what the second problem is it's an example of what we call conditional probability. Conditional probability is the probability of a second event happening given the first event has already occurred. I probably spelled occurred wrong, but anyways, let's just say happened. I know how to spell that every time. Given the first event has already happened. That's called conditional. There's a pre-set in stone condition, and that event has happened. It's in the past, so it's guaranteed to happen. I'm only worried about the future. And I think that gets some kids. They don't like the idea of given. They want to do everything. There is a formula for this. The probability, and notice how this is read. It's not read P A bar B. Probability of A given B is read that the probability of event A happening given event B has already occurred. And it has a formula because everything does. It's the probability of A and B over the probability of B. And notice the setup here. We kind of have almost a divisor here. That's in the bottom. That's how it is. And this would be, when we talk about A and B, we're talking about both happening. That's a both statement. The other way of writing this is using set notation. The probability of A given B, it's the N. I literally see A and B when I say that, when I do it, over the probability of B. So you need to be familiar with both. All right, so the next question I think is from a New York Regents test. In New York, they take Algebra 2, believe it or not, and they take a big exam at the end of the year called a Regents exam. And if you pass the exam, you pass the course, as long as your average in the class was high enough. If you fail the exam, you fail the course, and you have to retake the Regents exam. They have a big retake thing. You get a second chance, and if you fail it the second time, you have to retake Algebra 2. That's how New York works. All right, so a fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D, that a customer uses the drive-through, and events F, that a customer orders French fries, are independent. All right, the following data are given in a report. Now, if two events are independent events do not influence each other. Conditional probability is a dependent situation. Notice how we talked about in the definition, second event happening given a first event has already happened. Conditional probability is dependent probability. So I'm going to spend some more time on this, okay? So I already know the answer is 0.8. I know it is because the probability of F given D happening is going to be 0.8 because they are independent. Now, if I try and do my formula, this is where we run into a mistake here. If we did the probability of event F happening given D has occurred, we would write down the probability of F given D, but it'd be over the I don't know why I'm writing F there. It would be over the probability of event D happening. And they never gave us event D. So there's no way to come up with this idea, but you just have to read the frickin' text. That's what it's there for. Read the text and focus on independent, because conditional is not independent, it's dependent probability. All right, next one up here on this page. Consider the probability statements regarding events A and B below. The probability of event A or B is 3/10. The probability of A and B is 2/10. The probability of A given B is 8/10. What is the probability of event B? They have given us too much information, all right? They have given us too much information, but they gave us this guy, which is awesome. They gave us these two right here. Because if I think about the formula I just wrote down, the probability of events A and B is the probability of event A happening given B has occurred is the probability of A and B over, there's a bottom, the probability of event B. And they gave us everything we needed. I can plug some stuff in. I know that this piece becomes 8/10. 0.8 equals A and B is going to be 0.2, and I just need to know this guy down here, the probability of event B. It's legit easy peasy if you understand any algebra at all. Most of you be like, Milbrath, I need your help because I don't know how to do this because I ain't paid any attention all year and I can't have more than one column of thought. That's what you'll do. You multiply both sides by the probability of event B. Some of you guys just have an issue with not realizing, like you see a different letter and you freak out. Cancellation on the right. 8/10 of the probability of event B is 2/10. Divide out the 8/10. And I guess since you're busting pushers, whatever, you'll have to go to a calculator. But the probability of event B is going to be 0.25 because 2/10 over 8/10 is like looking at 2 over 8, which is like looking at 1 over 4, which is going to be 0.25. Or a quarter. I like a quarter. New York regions, they use decimals. They do. Moving forward, the probability of rain on, that says rain of Wednesday. The probability of rain on Wednesday and Tuesday is 45%. The probability of rain on Wednesday, given it has rained on Tuesday. Now remember, I told you the other day that weather is a dependent situation. It is an overlapping situation. What is the probability of rain on a Tuesday? All right, so let's set this one up. We're talking about Wednesday and Tuesday, and I have something that says the probability of rain on Wednesday given it has rained on Tuesday. So this would be the probability of Wednesday given Tuesday. And I'm going to think about my setups. The bottom is Tuesday. That's the probability of Tuesday. The top is going to be the probability of Wednesday and Tuesday. and I'm going to feed a formula. That's all I'm going to do. I'm going to feed this thing some numbers. So I know that Wednesday and Tuesday is 45%. I'm just going to leave this 45. The probability of Wednesday given in his rain on Tuesday is 60%. So this guy becomes a 60. And I just need to know what this probability of Tuesday is. It's exactly the same thing I just did. I multiply both sides by the probability of Tuesday. And again, if you're saying P of T, you're part of the problem. Probability given it's Tuesday, or on Tuesday. So I have 6/10 of the probability of Tuesday. That's not 6/10. I have 60 because I didn't use decimals. Oh, wait. 60 probabilities of Tuesday is equal to 45. Divide out the 60. And we will get 0.75 or 75%. 75% chance of rain on Tuesday. Weather is dependent. Okay, weather is a dependent situation. Here we have a mix of old and new. These are called two-way tables. This one's actually more than two-way, but anyways, got a table. We're going to analyze a table. Find the probability a student visited tutoring given they were part-time or full-time. And I need to revisit that question. Visit tutoring, let's say 2 to 3 times a week. And I don't like the way that's worded. I like this better. Given they were a full-time student. So I know they're going to be a full-time student. There are 45 full-time students. That's my divisor. Now, 2 to 3 times a week is going to be this guy, 25 and 45, which we can reduce that on down. Both of those are by 5, so that's going to be 5 over 9. If you like decimals, it's going to be 0.555 with a bar. If you like percentages, it's about 55.55%. I know you don't know that, but if you divide by a 9, you get 11. Pay attention to patterns and numbers. See the 0.111? So, 25 over 45, 0.555. And it doesn't stop at 6, you dumb. That's a rounding on the calculator. All right, find the probability that a student attended tutoring and was a full-time student. So they go to tutoring and they're full-time. So this is something that we call overlap. And it's also the both situation. There are 58 total students. And the and thing here is what we call the overlap. It's the both. So I want to know about the students that attended tutoring and were full-time kids. Well, there's 45 of them. Right? They've gone to tutoring. There's 45 out of 48. So 45. I really should have ordered that one a little bit different. But I didn't. And I just don't like the way these are worded. Give me just a second here. I'm going to reword 3. Find the probability that a student attended tutoring given they were a full-time student. I really didn't like the way I worded any of those. They're all horrible. Bad Milbrath. I was multitasking on this during second period. And I got kind of thrown off. Let's see here. So anyways, what do I want to change this one to? Find the probability. We've already done a given one. So let's do something else. Find the probability that a student attends tutoring two to four or more times a week, or is full-time. This is better. We attend tutoring 2 to 4 or more times a week, or is full-time. So it's going to be a large table, and there are formulas that we can use, but we don't have to use them with tables. So let's just kind of look at things here. So we pick some random kid, and I'm interested in 2 or 4 or more. That's those guys. Or is full-time. So I'm also interested in that guy. Now, aren't I? It's that. It's 45 and 58. That's simple. All right, there you go. There's that. There's the table. Here we have a Venn diagram. I actually enjoy Venn diagrams. A lot of people do not, but it is what it is. Data from students enrolled in a local high school are shown in the Venn diagram. If a student from the high school is selected at random, what is the probability that the student is a sophomore given they're in Algebra 2? So this piece right here is what we call the overlap. It represents the probability of events A and B. That's what it represents. Now, there are more than 210 kids in Algebra 2. Algebra 2 has this piece of 85 and then 210. There are 210 plus 85 kids in Algebra 2. All right? So there's 295 total. So I talk about the given that I'm in Algebra 2, I need to be thinking about out of 295. So here the probability is 85 in 295. I like Venn diagrams. I will probably have an entire lesson dedicated to Venn diagrams. Most kids will treat it as garbage and they won't want to ever look at them again, but they are a really good thing for a visual person. Anyways, I should reduce that 85 over 295. 59. Hopefully it's 17 over 59. Yeah. 1759. Of course, if you like the decimal, there's your decimal, 0.2881. The set of data in the table below shows the results of a survey on the number of messages that people of different ages text on their cell phones each month. I guess we should just change this to messaging in general, not text messages. What is the probability that a person sends over 50 text messages per month given they are in the 23 to 60 age group? So this is what matters, the 23 to 60 age group. That's the only thing that matters. And it's given, okay? They're going to be in that group. Now, I need to do a little adding here. This one doesn't do it. So I need to figure out how many total people are in that group. There's 25 plus 47 plus 157. There's 229 people in that group. All right. Over 50 is 157. And then I reduce the fraction, which I don't think that thing reduces. I really don't. It doesn't look like it's divisible by 7 or 3. But I could be wrong. It happens a lot. Yeah, that's as far as it goes. Maybe the decimal 0.6856. There's probability of that event happening. What is the probability that a person sends between 11 to 50 text messages per month and is in between 19 to 70? Okay, so we've got some work to do here. And I like tables don't require formulas, but you'll notice I'm highlighting. I send between 11 to 50, that's going to be this column, and is between 19 and 60. So that's going to include that guy, that guy, that guy, and that guy. That's most of it. Now, one thing I've never yet to do is I've yet to come up with true tallies here. how many people are in this thing? There was 229 here. And boy, I'm tired. Should be 118 there. Should be 109 here. And then we add down. Just going to go old school here. 446 people. So it's going to be out of 446. And I can be a little lazy here since I'm everything but the 68 and 4. If I made a mistake in my basic arithmetic, feel free to correct me and laugh at me. Don't care. 374 out of 446. And that will reduce. Those are even numbers, so we know it's going to reduce. $187 and really that's as far as it went. 187 and 223. All right, last one. 2 dice are rolled. Find the probability that their sum is not 10 given the first die is a 4. So not 10 given the first die is a 4. This is the complement of being, or sorry, of having a sum of 10 given the first is 4. All right. So what I'm going to do is I'm going to find the probability of having a sum of 4 given the first is 4. Or sorry, having a sum of 10 given the first is 4. Now, if the first die is 4, and that's a fact, the next one is 6, because 4 plus 6 is 10. This has to be true. And the probability of getting a 6 is 1 in 6. So this right here is the probability of sum of 10 given a roll of 4. It's 1 of 6. And I want the exact opposite of that. I want the complement of this event. So I don't know if you remember this or not, but to denote a complement, we would just put a not over it, of not sum of 10 over a roll of 4. And it's going to be 1 minus 1/6, which is 5/6. And of course, you could have gotten there by saying, Milbrath, that's easy. The next one can be a 1, it can be a 2, it can be a 3, it can be a 4, and it can be a 6 or 5. That's valid. But my job is to teach you what a complement is, so why not? There you go. And that is going to be 12-2. Next up for me is to record 12-1, which is way, way longer, and I don't really want to do it. But here we go.